If you Google CCIE still relevant, you'll find all these hits from people asking that question. Does it matter? You know, we're in the world of SDN, everything's different. Do we still need a CCIE?
Wanna shake that ground, wanna break away, let loose. I'm tired of waiting, gotta make that move.
Hey everyone, it's David Bombal coming to you from Cisco in San Jose. Very happy to be speaking to Jeff. So Jeff, could you introduce yourself so that I don't mess it up?
Sure. So my name is Jeff McLaughlin. I'm a Director of Technical Marketing here at Enterprise, the Enterprise Networking Business Unit at Cisco. So Enterprise Networking covers routers, switches, wireless, DNA Center, software-defined access, identity services engine. So it's quite a broad range of products, but like I always say, don't let the words director and marketing scare you. I'm a very technical person. I have a very technical background. That's where I come from. So.
Yeah, I was going to say, because when we were speaking offline, you were saying that you're actually a CCIE, and I'll let you fill in all the blanks, but you're a director in marketing.
Technical marketing.
Oh, technical marketing. But it mustn't insult you now.
So we're not doing like fluffy, high level, we are technical. Maybe I should actually explain what technical marketing is. So first of all, to fill in your blanks, CCIE route switch, CCIE security, got a certification from the other guys, JNCIE service provider. So as far as technical marketing, it's very simple. We do a couple of things. One is we go out and explain what our products do. So that's like going to Cisco Live, working with account teams so that they understand at a technical level how to deploy our products, how to use them, especially the newest stuff that's coming out. And then we also have an inbound function where as we do those interactions with customers and with our salespeople, we learn like what we need to build into our products, and we work with product managers to get that implemented. So we're guiding and partnering with engineering as well. So it's kind of a role that has two different directions. Both of them are definitely interesting, but both very technical.
Yeah, I mean, when we were talking earlier before we started recording, you told me about a session that you've presented at Cisco, and I don't want to spoil it. It was something like CCIEs are irrelevant, and I'm just mocking.
Well, that's actually a good way to start it. So the title, it's a Cisco Live session. I did it, I've done it twice now. I did it at Cisco Live Barcelona earlier this year and at Cisco Live Melbourne, or Melbourne, if I say it correctly. And the title of the session is the CCIE in an SDN world. Okay, so, and to use your words, I actually begin the session by asking the question, is the CCIE relevant anymore? In fact, I put up a slide with Google search results. If you Google CCIE still relevant, you'll find all these hits from people asking that question. Does it matter? We're in the world of SDN, everything's different. Do we still need a CCIE? And so the point of the session, I'll tell you my conclusion in advance. My conclusion is yes, it is still relevant. The program will adapt. I don't work, by the way, in the certification program. I do work with them, but this is my opinion as someone working in the business unit. But yes, it is still relevant. It will adapt. You're going to have to learn some new things, but that's what we like about our job, right? Exactly. We're always learning new things.
So tell us more about the session. Can you share a bit of details, sort of like informally, why you say it's still relevant?
Yeah, so, and again, the session, when it starts out, I'm asking why it's relevant. I actually, I say, hey, look, we've gotten rid of bank tellers with automatic teller machines. Or maybe we're going to get rid of taxi drivers with self-driving cars. We're going to get rid of network engineers with all these new automation products. And then I dive into two things, really. I focus on device level programmability, so that's netconf, Yang, Ansible, that kind of automation of devices, device by device. And then I look at DNA Center as an example, and software-defined access specifically as an example of SDN, because we don't really call netconf Yang SDN, although you could argue it is. So we look at both. So in terms of why are we still relevant, if you look at the netconf Yang stuff, so if we take that perspective that APIs are going to get rid of CCIEs, you're no longer going to need to know CLI. If you look at netconf Yang, for example, if you look at the iOS XE, that's what I work on, the iOS XE native data models, that is the structured data that describes all the stuff you would do with CLI, whether it's going into config T and router BGP or looking at show interface output. So this is the structured data models for basically the APIs for doing that. It's structured very closely to what you would do at the CLI level. So my point there is you cannot do that kind of configuration of network devices unless you actually understand what you're automating. Yeah. So let's say tomorrow, or this year, all the CLI goes away. We're no longer doing it. We're doing netconf yang. You still need to understand network engineering and the fundamental principles, or you won't get anywhere with that. So that's the first point. The second half, I talk about software-defined access, and like I said, that's just one example. I mean, ACI is another example of the same kind of thing. And what I say there is, yes, it is automating a lot for you. So now if you want to add a device to your fabric, you click, there's a menu, add to fabric, save, and it's done, right? You're not doing all that CLI. But the point is, networks are still networks. At the end of the day, you're automating something which is still complex. And what's happening is, from a network engineer perspective, the complexity, I think, has shifted a bit. Like, this saves you the trouble of going device by device by device, doing CLI config, but you have to think bigger picture. Like, how are you going to put this solution together? How is ICE going to interact with it? How are you going to do the segmentation for the network? How are you going to connect to external environments that don't have a fabric? And the point I always make with any automation technology is the banging on the keyboard for 100, 500, 1,000 devices part of your job is not where you're adding value, right? Like, you're adding value by designing networks, by troubleshooting problems, that kind of stuff. And that's going to be there. And an analogy I like to use, and it's actually particularly relevant these days, I have a pilot's license, and I love airplanes. And even if your viewers don't have a pilot's license, you may, if you remember what an old airplane cockpit looked like, it had all these dials and gauges and stuff. And if you wanted to go flying on instruments, like in the clouds where you can't see anything, you'd be sitting there holding the stick or the wheel, looking at these needles, trying to keep them centered. And it's a very tedious operation. So now, with even small airplanes, they have a fully automated cockpit. You put in your flight plan. You don't have to sit there. You put on the autopilot, and it does what you want. And you focus more on what's relevant to you, which is figuring out how you're going to navigate, interacting with air traffic control, setting up your instruments in advance. A lot of people say, well, that's an interesting analogy to bring up because we've had some airplane disasters recently related to automation systems. Yeah, exactly. But that proves the point. Yeah. It proves the point, though, that you still need human beings who understand and are fully aware of what those automation systems are doing in case something doesn't happen. And in those cases, people weren't fully aware of what the systems were doing, right? Yeah. So that was a very long-winded answer to your question.
That's great. Yeah. Jeff, that's fantastic. Questions I always get. So I'm going to run a whole bunch of questions by you and just give us your opinion. Okay. If I was a young person today entering the network industry, so looking to get my CCNA, so first thing is networking still a good career?
The answer to that is unequivocally yes. And the reason is networks aren't going anywhere. They're still here. They're still the backbone of the internet and everything we do. They're going to change, but I would certainly think it's a good career for the foreseeable future, I'd say. Yeah.
So, you've got, did you say double CCIE, and you've done Juniper, is that right?
Yeah.
Forgive me if I've got that wrong. But
yeah, you got it right.
So, if you were starting out today, would you, with what you see happening in the industry, and obviously you've got a nice view of what's going on, would you suggest a young person go and study CCNA, CCNP, CCIE, or would they go to CCNA Python?
Well, I think that my earlier point is very important, which is that you have to, if you're going to automate, I don't care if it's Python or something else, you have to understand what you're automating. So I think if I were starting out, I would do, I do CCNA, which I did many years ago, and at some point I might bring in some Python. It might be early, but I wouldn't stop the CC whatever track at that point. Like, I'd keep going, because if you reach the deep level of knowledge of network engineering of a CCIE, by the way, that's not the top. You keep going. You know perfectly well. That's just sort of where you...
Feels like the start sometimes.
Yeah, I heard from someone who has a black belt, that you get your black belt in the martial art, that's when you start to learn.
It's interesting, yeah.
Yeah, so I don't think it's an either or. In other words, I think you could, in fact, if you spend one weekend with a beginner Python course, and then maybe another weekend going through Cisco DevNet on netconf Yang or something like that, APIs, there's a huge value in just that much of an investment of your time. So the short answer is do both.
I'm glad you said that, because that's what most people, people like yourself who've been in the industry for a long time are suggesting.
Yeah.
It's not an either or.
Yeah, and keep in mind, we're at the beginning of a transformation. One of the slides that I put up in my session is a study from Gartner, and they found that 70% of networks are still configured using CLI and doing it the manual way. So you may be in a good position to go into one of those companies and help them achieve this transformation, but you got to know the CLI that they're currently using to manage their network in order to do that.
Do you have any favorite network automation tools? A lot of guys argue Ansible versus Python.
So, if we leave out the DNA Center thing,
let's come to that.
We'll talk about the open source kind of model. Ansible is a very good way to get started. It's a really good way to get started because you don't have to worry about writing an entire Python script, for example. And if it does what you need, then Ansible, I think, is a very good way to go, or a similar tool. Right now, I think Ansible has the most networking features. Puppet's doing some work as well. Where Python comes in is if you need to do something heavily custom, I think. Something that Ansible doesn't have built into the modules it uses for say, Cisco devices. Or maybe you want to do something more creative, like read some data out of a switch, parse it, and then post that to a WebEx Teams room, or text message someone with some results, or analyze the data in some way and look for a particular piece of information. That's when you need to get into Python. To your point, I could even modify what I said earlier. If you want to do the CCNA and get into Ansible or a similar tool, that's a good route to go as well. But it's always good to have a few tools in your tool bag. And the more of those things you have on your resume as you're looking around, the better off you are.
That's a great point. I think a lot of people get stuck on this, especially in the beginning. It's either or.
Yeah.
I think I said, but it's, as you said, the more you have, the better.
The first time I did, I don't even know if it's still there, I did a dCloud demo on the Nexus when I was on the data center side for Ansible. And I got assigned that, and I hadn't even worked with Ansible, and I had to write a demo. And, I figured it out in a couple of days. So it's really not an either or. It's something you can pick up pretty quickly. Python, learning to become a good Python coder might be a bit more of an investment. But again, you can still get the basics down and already see the advantages of that pretty quickly.
We've spoken now about the open source stuff. And I don't know if you wanted to say more about that. But Cisco, you said your talk was CCIE in the SDN world. Yeah. So here's the typical question. Jeff, what is SDN?
I raised this point in my talk because if you look at it, technically, this is why we prefer the term intent-based networking here, which I think is a better term. It's not just a marketing thing. If you actually look at it, it describes it better. But when back before SDN existed, if you went onto a device and configured a BGP peer, router BGP, you were defining your network with software. I hate to tell you. You're interacting with software. That's a software process running on a device. It was software. So, SDN's a bit of a buzzword. What I liked about intent-based networking was, I like to use analogies. So here's another one if the airplane one didn't get you. I bought a house recently, which in California means I'll be living on bread and water for the next 25 years. But, I've never owned a house. I've rented my whole life. And I inherited a garden, which is great, with a sprinkler system. And it had this antiquated system with a dial on it, and you have to go zone by zone and set the minutes. And I don't know if it's raining, am I supposed to dial it down? How much? If it's hot out, should I water more frequently? What does a hydrangea need versus a lawn? People nowadays don't want to think through those details. They just want a result. My result is I want my plants to look nice. So I ripped that thing out and I put in a Wi-Fi based, IoT type of sprinkler system. It gets the weather in real time. It adjusts the times for me. I tell it what kind of plants I have, and it just does it. Yeah. Similarly, the idea of intent-based networking is, again, if I want to add a switch to a fabric and I'm using software-defined access, that involves VXLAN, Lisp, TrustSec, a number of different components, maybe .1x. I'm at a point where I just kind of want to add it to the fabric and have it work. I don't want to have to sit there and think through all of those different components. Now, that said, what we're talking about is a different model from the original definitions of SDN that you saw. Because in the early days, what it meant was that you would have a controller, which was an external device of some kind, and your network forwarding elements were just packet pushers, right? They did not have, they weren't doing the control plane stuff. It was outsourced to this controller. Systems with some sort of analytics capability built in as well, which I didn't even talk about that yet.
Lots to ask you. Go on.
Yeah. So it's a different model. If you look at DNAC, it's acting more as an automation analytics engine. It can function as a controller in certain circumstances, but for the most part, it's not. And I think it's a better model because, first of all, if the DNAC goes down, your network will continue forwarding. Which, in some cases with the external controllers, the way they were, they obviously thought about that problem. It wasn't like,
Yeah, but it is a problem.
Problem.
Let's talk about the elephant in the room. OpenFlow didn't deliver.
So I'll give you my official Cisco. We do support OpenFlow on iOS XE. We do have customers that are interested in it. But I will say this, we don't see a lot of adoption of it or interest in it. Yeah. I think there's a couple of things that are, as network engineers, I think we intuitively know that one of the reasons the local device had a control plane was that there's a value to local knowledge. Yeah. It knows and is able to act on its own based on information in a distributed model and make a forwarding decision. If that link goes down, I'm going to switch to this one. Now, when you outsource the control plane to something that's far away, you run into issues of how does the forwarding element communicate with that? How quickly can it respond? So I think that's why the industry's moved away from that model, whether it's OpenFlow. There are several others. There's still PCEP out there. I'm not sure. I don't work on the service provider side. That's more of an SP thing. I used to, but I don't anymore. So I'm not sure what the adoption is there. It was a similar model where you had the control plane out. Yeah. I mentioned the other component of it was the analytics piece. Just pushing config to a device, that's fine. That adds quite a bit of value. But if you look at a tool like DNA Center, it's also accumulating a huge amount of information from network devices, taking it in, analyzing it, and giving you suggested actions if something goes wrong, allowing you to do things like dynamic packet captures. For, say, a wireless client that's misbehaving, it'll actually analyze it for you. So that's an essential piece of that. It's both automation and analytics. I don't work too much on the assurance side. I know what it's doing. I'm more on the automation side, but they're both essential.
So going back to, we spoke about Python, Ansible, but let's talk about Cisco products now, because assume that I'm new to this. Yeah. So I've just done my CCNA. They kind of mention a little bit here and there, but can you give us the big picture of SDN, or we can use this term, explain what is intent-based networking, why is it called that, and I'm kind of giving you a big thing here, but Sure. What is SDN, what are the kind of the products that Cisco have, and kind of where they fit, if that's not too much?
No, no, it's not. It sort of all started in the data center, and there were certain challenges that arose in the data center that we realized needed a different kind of solution. So VLAN scaling, mobility of virtual machines. You have a big data center and you have a VM over here and you want to move it to a server over here. Well, if it requires VLAN 101 and that's on this server, not on this one, how do we make that work? Do we trunk every VLAN to every device, or do we? So there are all these interesting questions that were coming up in the data center. And that was when ACI came into the picture, which is a fabric using VXLAN. And again, I'm not an expert on ACI.
That's good though, because you can give it to us in layman's terms.
Yeah.
Go on.
So the idea of the data center fabric was to solve some of those issues and make it easier. So they're using VXLAN. On the campus side, we realized a couple of things. We're facing a number of interesting challenges, some of them very similar. For example, we have to deal with device mobility. It's not VM mobility, but people are carrying their devices all around. They're moving around the network. For example, the classic way we design networks with layer 2 up to the core, spanning tree, HSRP, that was the classic way. It's really not the best design. It works. We've built networks that way for a long time, but if a link goes down, it takes a long time to fail over, et cetera. Now, there were a variety of ways to solve that have been engineered. For example, spanning tree improvements like rapid spanning tree, box aggregation techniques like VSS or stackwise virtual, where we make two core devices look like one and we get rid of spanning tree. But the gold standard for a while has been the idea of a layer 3 routed network, where we put /32s or what have you on all of the links on the devices, and we run layer 3. The problem is that breaks your layer 2. So we realized that in the campus we have a number of issues which are very similar, if not identical, to the data center. And that's what SDA came out. It was, hey, why don't we take the same technology, VXLAN, that we use to solve these problems in the data center, bring it to the campus, but with a little bit of a campus twist, like we use Lisp instead of BGP for our control plane on the campus. We also we were already using Identity Services Engine, ICE, for campus security. So that's an integral part of software-defined access as well.
Yes, I'm glad you mentioned the name. So SDA is software-defined access.
Yeah.
And one of the questions I wanted to ask you is, can you define or tell us in layman's terms, or someone starting out, you've kind of mentioned it. So I mean, there's like replacing spanning tree and stuff like that.
There are a lot of terms and we tend to throw them around like everybody knows what they mean. So it's a good thing to take a step back. So I'll start with Cisco DNA.
Yeah.
That's Cisco Digital Network Architecture. And I always say that doesn't mean that we used to have analog network architectures. What it refers to is the fact that we're living in an increasingly digital world.
Yeah.
Because of IoT, the explosion of all these devices on networks. I was talking about sprinkler systems, their heaters, et cetera. Your vending machine is networked. We're just seeing a very different environment than we used to. When you and I started, for example, we had no wireless devices on our networks at all.
Exactly. Yeah.
Now people have 3 or 4 Wi-Fi devices at any time. I mean, you probably are consuming quite a few IP addresses on our network right now.
Exactly.
So that's what digital network architecture refers to. Cisco DNA Center is the controller component of that network architecture. So we talked a bit about what a controller is versus what it isn't, but basically that is the platform that does automation and analytics or assurance for the intent-based network.
Okay.
That's Cisco DNA Center. So that's a platform. Right now, you buy that as an appliance, and it's running this software called Cisco DNAC. Then we have software-defined access. Software-defined access, so you can buy Cisco DNAC and deploy it without doing software-defined access, and it can act as basically an automation engine. And what does that mean? Well, it will do things like automate your software upgrades for your devices and do plug and play, where if you get a switch out of the box and you plug it in your network, it auto configures itself and brings up a base config, that sort of thing. So it's a basic automation, and then it can also do the assurance component, which is, say, consuming analytics from your wireless controllers and telling you what the health of your network is, that sort of thing. Software-defined access is one component within, or an application really, within Cisco DNAC. And this is the software-defined networking component of it that provisions a campus fabric. So you wanted to know exactly what that means. I think if I flip it around and explain it from a user experience perspective.
That'd be great, yeah.
As network engineers, we want to know what's under the hood. What are the protocols? How does it? Let me explain it from a user experience perspective, and your viewers can always go and find demos online. There are a number of them that we have on YouTube as well. the basic idea, think about how you deploy a brand new network traditionally, right? You would get your switches, you'd have some that are maybe access switches and some that are distribution and core, or maybe you have a collapsed distribution and core layer. You get them out of the box, you start provisioning them by hand, you're going to TFTP or who knows what protocol, some images up to them, get them up to a current level. Then you're going to maybe configure one of them with a base config, put it in a notepad, copy, paste it in a bunch of other devices. You're going to configure probably certain number of VLANs, spanning tree, HSRP somewhere. Maybe you're doing VSS or something else. So you're going to be doing that all via CLI traditionally. Maybe with a little copy and paste. So I say Notepad is the primary automation tool for most network engineers. Software-defined access, what would happen is you cable up your devices, and then you use Cisco DNAC to discover those devices and auto-provision an underlay. Okay. What is an underlay? I think network engineers may not still be comfortable with the term, but it's very intuitive. If you ever provision a GRE tunnel, you know what an underlay is. Like maybe you have 20 hops in between the two ends of your GRE tunnel. That's the underlay. But when you look at the GRE tunnel, it's like a point-to-point link, right? All of those intermediate hops just kind of go away. Yeah. That's what a fabric is. So DNA Center will provision that underlay. It'll get all the basic routing up on those underlay devices, all those switches that you have in your network. It'll do that for you automatically. And then when you're ready, you can add those devices to your fabric, and that creates an overlay network. A lot like what GRE does, except we're using VXLAN. And it's a multi-point kind of thing. GRE, its basic implementation is a point-to-point technology. The idea of that is that it abstracts away the detail of the underlay network so that you have a device on switch A and a device on switch B. It doesn't matter what intermediate nodes, what /32s or layer 3 is in between them. It just looks like they're on the same network, which is what any overlay does if you think about it. So that's the fabric component of Cisco DNAC. As I said, you don't have to deploy software-defined access, but that's for us sort of the gold standard, or right now the best way to handle a network that's dealing with the explosion of devices, the issues of mobility, the desire to have fast failover if a link goes down, while maintaining the ability to have layer 2 stretched from point A to point B, and also maintaining a very good security policy. And that's another subject in and of itself, which I can talk about.
So the idea is, is SD-Access, software-defined access, is that right?
That's right.
That's for a campus type topology.
Yes.
So the idea is you have like all your physical devices, but then like the underlay runs some kind of technology that's automatically deployed. Yeah. But what's the advantage? I mean, I think you've kind of said it, but like, can you explain? Why would a network engineer or someone tell their management this is the way to go?
There are a couple of things, and I mentioned simply the fact that it moves you away from the traditional layer 2 networking. You have much faster failover if links go down, while maintaining the ability to stretch layer 2. There's also the security of your network is very much improved by doing it this way. Let me explain why, because I didn't get into that. Yeah. How have we done security traditionally? Well, badly. Okay, I'll give you an example. I won't say what company. I worked for this one company, and they had firewalls all over the place in their network. And they had a security policy on one of the firewalls that was 300 pages when I printed it out in 12-point font, so I could start reviewing it and figuring out what they'd just been putting stuff in these firewalls for years. And I looked at the very first line of it, and it said, permit any. And what happened was someone had put that in there for troubleshooting when they had an outage, and they forgot to take it out. Oh, wow. And so they kept adding stuff in, and they never knew that the firewall did absolutely nothing. But that's very typical. I mean, we've had, so at the layer 2 level, we've had things like private VLANs, which I don't see that much deployment of it. We do have some customers that deploy it, but it's not ubiquitous by any means. We have layer 2 VACLs, VLAN access lists, and stuff like that, which most people don't use a lot of. I mean, I don't know about your experience, but I don't think it's kind of scary to put a layer 2 ACL in your network because things will break and you won't know. And then maybe there's some basic ACLs at your core, and then you have a firewall somewhere. Problem with this, if you think about it, let's say I want, I have different groups within my company. I have HR and finance, and I don't want them to communicate with each other. How do I do that? Well, I have to put them in separate VLANs/subnets, and I have to have them go through a firewall somewhere in my network and back down. So we've had a technology for a while called TrustSec, or group-based policy. And the idea is that you authenticate in, say, to your Active Directory. We have preferably .1x enabled, 802.1x. And the end result of this is that not only does Active Directory say that the user Jeff is in HR, let's say, but that also gets communicated to the network down to the switch. And then the network can assign a tag to you. So as your traffic transits the network, there's a tag attached to it. We're not doing this based on IP address anymore, and we can do policy, permit, deny, whatever, based on that tag. Now, with a software-defined access fabric, that tag is a part of the fabric header. And so every packet that moves through that fabric has that. So the end result of that is I can put an HR user and a finance user in the same subnet, the same VLAN, and we say they can't talk, they can't talk.
That's cool, yeah.
Now what we did with SD-Access is we added a secondary layer, a macro layer on top of that called virtual networks. So you might take HR and finance and engineering and put them in your employees' virtual network. And then auditing and accounting or whatever are in your contractors' network. This is more of a blunt tool. It won't do that segmentation at the inside of VLAN. But what it enables you to do is to have a very hard separation between different classes of traffic and enforce that separation typically through a firewall or something. Where customers often use this is for guest. So they'll put guest traffic in a VN and it's separate and it will not talk to the employees unless you specifically put a firewall and policy for that. So we've added that security construct. That's built in with SD-Access. So that's something when I worked in IT in my last job, the CISO, Chief Information Security Officer, she used to ask for that all the time. But now we can deliver it, microsegmentation.
That's great.
So those are some of the advantages of SD-Access. I'm sure there are more.
Is there any interaction between ACI and what you're talking about now and then I want to ask you what you're excited about for the future.
Well, I think they probably kind of tie in together. So, one question that comes up a lot is you mentioned that you have SD-Access in the campus, and you have ACI in the data center. ACI has policy constructs similar to SD-Access. Can they talk? And the answer is yes, they can. We can use ICE to unite those together at the policy layer and map the two policy constructs together so that you can have end-to-end policy. We're going to be doing more with that integration in future releases to make it tighter. And we're also integrating SD-WAN as well, which is our basically the product we acquired from Viptela as our software-defined WAN technology. We'll be integrating with that as well. I'm not an expert on SD-WAN, so I can't get too deep into that for you. But that is what's very exciting for me, is seeing these technologies start to come together.
So, if you were throwing the question back again at someone who's starting today,
yeah.
They get CCNA. If this is just your personal opinion,
yeah.
what do you think is the most exciting technology that you would jump into?
I would certainly look at the intent-based networking stuff that we're doing now, campus, data center, et cetera. I would definitely look at software-defined access because more and more customers are going to be asking about this. And one of the things, so when you're getting started, I'll give advice to your viewers. You have a couple of things to do. Number one, you have to establish yourself that you understand the baseline knowledge that a network engineer should have. And again, going back to what I said earlier, that's where you do your CCNA, you do your CCNP, maybe you go all the way to CCIE, but whatever you do, and not just the certifications, but you get hands-on experience. That can be the hardest part, but getting hired somewhere where you can actually work on networks. On the other hand, you need to make yourself marketable. Yeah. And how do you make yourself marketable? I know I work in marketing. I know I said that it's technical marketing, but it's still marketing.
I was going to say, you're contradicting yourself now. No kidding.
Everybody has to market themselves.
Definitely,
a little bit. I think people forget that.
Yeah.
And so marketing yourself involves distinguishing yourself from other people.
Yeah.
And how do you do that? Well, you want to have knowledge that is uncommon in the industry or other people don't have a lot of. That's where you dive into, if you know software-defined access, let's say, or SD-WAN, there may not be a lot of resumes in the stack that have that.
Exactly.
Now maybe you throw in Ansible. And by the way, I didn't even get into, you can use potentially Ansible to automate the automator.
I was going to ask you, is like the open source stuff separate to the Cisco stuff, or is it kind of integrated?
They can work together. And so part of my team, I can't remember if I mentioned it earlier, but they work on APIs from our controller platforms.
You didn't tell us that.
So I forgot. Well, that's a new part of my charter, so maybe I forgot. But I don't want to forget them because they're really good technical marketing engineers on that side, really good. So what their mission is, they are ensuring that for Cisco DNAC, for vManage, the Viptela controller, for Identity Services Engine, our security product, they're making sure that we have APIs clearly defined for all of those so that you could have an Ansible or a script access that. Now, the question that might come to mind is like, why would I want to do that? Wait, you just said Cisco DNAC is my automation tool. Why on earth would I want to go sit there and put some other layer? Yeah. Well, a tool like vManage or Cisco DNAC is very oriented around humans. So in other words, it's a GUI. If you're adding devices to the fabric, you're going selecting devices, clicking add to fabric, and that sort of thing. If you have a large-scale deployment, it might be more efficient to automate that process, to call an API that adds stuff to the fabric. So in that case, what a tool like Cisco DNAC is doing is providing an abstraction layer. So rather than writing a script that goes to each and every single network device and defining all the config and doing all of that, you're just going to one point and it's going and doing that stuff for you. So I got a little bit off topic with your question there. But if you get into any of those areas, I don't care if it's netconf yang with Python or Viptela software-defined WAN or Cisco DNAC or software-defined access, you're distinguishing yourself from the rest of the pack. The more the better. The more you can get your hands on, the better.
Yes, very good point. I think it's exactly right. You've got to market yourself because the way that you stand out is to be different.